All right, guys, today we're getting into our last two shortcut methods when we're dealing with triangles. We have angle, side, angle, and angle, angle, side. So when we talked about side, angle, side, we said the important piece was that the included angle was there. The angle was between the two sides. Angle, side, angle is very much the same. Notice those two angle marks on angle A and angle C. The side between those makes this angle, side, angle. So if we're matching these up, angle A matches up with angle D. Side AC matches up with side DF. And angle C matches up with angle F. Then we know that triangle ABC is congruent to triangle DEF. So angle, side, angle is where the side falls between the two angles. Whereas angle, angle, side, notice you still have those angle markings on A and C, but we have the random other side. And it could have been like side AB on that left triangle instead. It just can't be between the two angle markings. So angle A, again, matches up with angle D. Angle C matches up with angle F. But then BC matches up with EF. So triangle ABC is congruent to triangle DEF. So angle, side, angle, 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 side, different things. Make sure you make note and understand the difference between those two. Okay, so for this first example, it says, can the triangles be proven congruent with the information given in the diagram? If so, state the postulate or theorem you would use. So we need to look at the picture and the markings that are there and see if there's enough information for us to say that, yes, these triangles are congruent. So sometimes we can mark other things. Like I see vertical angles here in the middle, so I could put 3 arc marks there. I need to consider, can I mark any sides? And the answer to that's no. There's nothing there that tells me that I can mark any of those sides. Right now I just have angle, 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 which isn't one that we know. So this is going to be a no. Okay, so then looking at B, I have 2 angles marked already. The only thing I see is that they both are touching here, so they're sharing that same side. So then when I look at the picture, I have 2 angles and a side not in between. So our reason here, we would say yes by angle, angle, side. The side's not between the 2 angles. Looking at example C, again, I see vertical angles there. It's touching just to the vertex. I'm going to put double arcs to show that. This time I see that the side is in between the 2 angles. So in this case, yes, we can, but it would be angle, side, angle. Put the S between those 2 A's. All right, and then looking at example D, again, I see sides touching there. So GK and GK match up. So this time I see 2 sides marked and the angle in between. So I would say yes, and it would be by side, angle, side. Okay, so we have some proofs, and this time they didn't give us anything. So we're even going to have to write out our setup. So remember that we always have statements on the left, and we always have reasons on the right. So I'm going to put number 1 right here. And I don't know how many there are, so I can't put my proof statement yet because I don't know until we get there. I'm going to put number 1 over here. So BE is congruent to BC, and angle A is congruent to angle D. Our reason is given. And I look at the picture, BE and BC are marked, and angle A and angle D are marked. So then I want to look and see, is there anything I can mark in the picture, just like we did on the example before. So if I look in this picture, I see right here the vertical angles, I can mark that. So we have to be specific though. I can't call that angle B because angle B could mean a lot of different things. So I'm going to label it with 3 letters. So B is my vertex, so it goes in the middle. So I have angle ABE is congruent to, and I want to do the same thing on the right hand side. So angle DBC. We said those are vertical angles, so our reason is vertical angles congruence theorem. All right, so now let's look at the picture and see what we have. Looks to me like we have 2 pairs of angles and a side, so that should be enough information. So looking at that side, it's not between the 2 angles. So that means that we have proven these triangles congruent by angle, angle, side. Then I need to write my proof statement over here on the left-hand side. And it's up above, it says triangle ABE is congruent to triangle DBC. And we're done. All right, let's try one more proof. So again, I'm going to put statements on the left, and I'm going to put reasons on the right, and I'm going to set up my table. So number 1, I'm going to put my given information. VW is congruent to XY. WX is congruent to YV. I'll put given. If you are feeling pretty confident on proofs, now would be a great time to pause the video so that you could try this on your own. So I'm going to keep going. So I have those sides marked in the picture, and so I'm looking. Where is it connected? What else could I mark? And I see that it's connected on the center line. So I want to be very careful here, though, because we've talked about that order is important, and order does matter when we're naming triangles. So if I look at the top triangle, and I'm going on the top triangle from this single tick mark, that's at point V, down to the double tick mark side at point X. So I'm going to put VX here. And I put is congruent to. Now look at the bottom triangle. If I want to start on the side where the single tick mark is, I'm starting at point X. And I'm traveling up to point V where the double tick marks are. So it's not going to look like VX and VX. It looks like VX is congruent to XV. It's a little tricky to see. The triangles are just kind of flipped around. But our reasoning still, it's the same side that's congruent to itself, so it's the reflexive property. And it's the property of, and I'm using the congruency symbol, so property of congruence. All right, now I see I've marked all 3 sides of both triangles, so I can go ahead and put that proof statement down. Triangle WXV is congruent to triangle YVX. Our reason is side, side, side. And we're there once we've proven those triangles are congruent. Okay, so as always, come in and see me if you have questions. Have a great day.